Hey guys, it's Mr. Tracy. We are going to continue with circles today, coming from my backyard. My wife is making a video too, so I came out here because it's beautiful out and it's nice and quiet. So today we're going to be talking about tangent lines. All right. What is a tangent line? Well, you guys have seen this word before when we were doing trigonometry. You guys like to just call it tan, but it's actually tangents. And what a tangent line is that a tangent line intersects a circle at exactly how many points? Well, AB is the tangent line here. How many points does it touch the circle? Just one at A. And that's exactly what a tangent line is. Okay? All a tangent line is a line that intersects a circle at exactly 1 point. Whoops. Ew, I hate that E. And that point where it intersects is called the point of tangency. Alright? There's one other thing that you need to know about a tangent line, okay? Is that a line is tangent to a circle if and only if it is, here's a word, perpendicular. Okay? If it's perpendicular to a radius drawn to the point of tangency. Sorry, a big truck just went by. It was kind of hard to hear. Okay, so what's this saying? A line is tangent to a circle if and only if it is perpendicular to a radius. What's the radius in this picture here? Well, the radius is AP. The tangent line is AB. So if that's the case, AB is tangent and AP is the radius, that means that there's a right angle here at A. Okay? And those are the two major things that you need to know about a tangent line. One, it intersects with a circle at 1 point. Two, at that point of tangency, there is a 90-degree angle that's made with the radius. All right? All right. Using that information, let's try a couple of examples. It says, determine if AB is tangent to circle P. All right, well, it definitely looks like AB intersects with the circle at 1 point, which is what it says, so that's true. But it also says a line is tangent to a circle if and only if it is perpendicular to a radius. So in order for AB to be a tangent line, that means, remember, perpendicular means creates right angles. That means that there has to be a right angle here. Does anybody see a shape that we should be extremely familiar with? I see a right triangle. 8, 15, 17. I see a right triangle. Well, how can I determine if this truly is a 90-degree angle? Well, if this is a right triangle, that means that the Pythagorean theorem, a squared plus b squared equals c squared, should work on this triangle for the 8 and 15 being the A and the B, and 17, since it's the hypotenuse, because it's across from the right angle, would be our C. So we're going to pop these into the Pythagorean theorem and see if it works. If it does work, that means that AB is tangent to the circle. All right. Remember, A and B are my legs, the ones that are not the hypotenuse. So 8 squared plus 15 squared equals 17 squared. 8 squared, of course, is 16, right? No! 8 to the second power is not 8 times 2. 8 to the second power is 8 times 8, which is 64. Plus 15 squared, that's 30, right? No! 15 to the second power is 15 times 15, which is actually 225. And then 17 to the second power, that's 17 times 17, which is 289. I always forget that one. Okay. And when I add these two up, 225 plus 64, I have my calculator. 64 plus 225 is 289, so I'm left with 289 equals 289. So, is this a tangent line? Absolutely. AB is tangent because I know for a fact now that this is a right triangle, which means that this is a 90-degree angle, which means AB is tangent to the circle. All right, let's try another one. Determine, same thing, if AB is tangent to the line. Okay, well, this one is a little misleading because since the 5 is out here, we have to assume that just this little piece here is 5. Okay, if this little piece here is 5, that means I technically don't have this other part of BP. Anybody see it? Anybody know what's the measure of this right here? Well, it looks like AP, which is what piece of the circle is this if it goes from the center to the outside? Well, this is a radius, right? Okay. And take a look at this little piece here. This little piece is also, it goes from the center to the outside, so this is also a radius. Does the radius of a circle ever change? No. The radius of the circle, no matter where you draw the radius, is going to be the same all the way around, no matter what, the same exact distance. So if the radius is 11 here, that means this radius has to be 11 here, which means this would be 16 units long. All right. Now we have to determine, is AB a tangent line? All right, well, if this is a tangent line, supposedly, not supposedly, if it's a tangent line, that means that at A, I have a right angle. So let's test Pythagorean theorem and see if this is a right triangle. Which one would be my hypotenuse here? Remember, the A and the B don't can interchange, but the C has to be my hypotenuse. Well, if this is the right angle, since this is the point of tangency here, that means 16 would have to be my C. So if I wanted to test this, I would do 14 squared plus 11 squared equals 16 squared. 14 squared plus 11 squared equals 16 squared. Let's test this out. 14 squared is 196. 11 squared is 11 times 11, which is 121. And 16 squared is 256. So if I add these two together, 196 plus 121, 196 plus 121 is 317. Okay, so this plus this is 317 equals 256. Does this make sense? This definitely does not make sense. 317 doesn't equal 256, so not a tangent line. Okay, that means that AB technically is not a tangent line. All right, let's try some more. If JK is tangent to circle L, find X. No, it's basically the same thing here. Okay, we're just going to use Pythagorean theorem and test to see, is this a is JK a tangent line in all of these? All right. Okay, so if JK is tangent, we have to find, they're saying that JK is tangent, sorry. We have to find X. All right, so if JK is tangent, that means that at the point of tangency, or the point where it touches the circle, that means there's a right angle there, which means we have a right triangle here, which means that if this is a right triangle, that means it would have to fall into Pythagorean theorem. Which one would be my C? 7, 19, or X? Remember, C is always the hypotenuse. So this would be, X would be my hypotenuse. So let's check, let's set this up into an equation. 7 squared plus 19 squared equals X squared. 7 squared is 49 plus 19 squared, I always forget that one. 19 squared is 361 equals x squared. And then 49 plus 361 is 410 equals x squared. How do I get rid of an exponent of 2? Who remembers? Yes, you are right. We have to take the square root of both sides. And then I get x equals the square root of 410, which is 20.24845673. Does it say round to the nearest whatever? It does not. So let's round to the nearest tenth today. So we'll call this, since the square root of 410 is 20.24, we'll round that and we'll call it 20.2. All right, moving on. So remember, for all of these, JK is tangent. Okay, so they're saying here's the tangent line. All right, at the point of tangency, which one's the point of tangency here? Remember, the point of tangency is the point that it touches the circle. So J would be the point of tangency, which means at J there should be a right angle, which means this is a right triangle, which means in order to solve for x, I need to use Pythagorean theorem. However, this 7 is talking about just the outside here. I need to know, in order to use Pythagorean theorem, I need to know how long LK is, the entire thing. So how long is this piece in here? Well, JL is a radius and it's 11. It looks like L to out here is a radius, which means this has to be 11 as well. Which means that LK is how long? 18. And now we're going to do Pythagorean theorem. My hypotenuse is 18, so that's my C. And I'm going to do 11 squared plus x squared equals 18 squared. 11 squared plus x squared equals 18 squared. 11 squared is 121. 18 squared, I always forget that one too, man. I'm rusty on my perfect squares. 324. All right, looks like I have to subtract 121 out. And I get x squared equals 324 minus 121 is 203. And last but not least, in order to get rid of an exponent of 2, we square root. And the square root of 203 is 14.247. Okay, 14.247. So if we're rounding to the nearest tenth, it would be 14.24, so we'd leave it at 14.2. And for all of these, we're only solving for x, so we're done. Alrighty, let's try another. Okay, JK is tangent, which means at J there's a right angle. Hey guys, don't worry about number 5. Number 5 is a little weird. It's not one that I'm too concerned about, so we're just going to skip it and move on to number 6. All right, so JK is tangent, okay, which means that at point J we have a 90-degree angle. We got to solve for x. So this would which one would be my hypotenuse? This one, the diameter, the tangent line, or this line, MK? Which one would be the hypotenuse if I'm using Pythagorean theorem? It would definitely be the 25, because it's across from the right angle. All right, so these are my two legs, x and MJ. How long is MJ? Well, LJ is 11, which means ML is also 11, which means this whole thing has to be 22. All right. All right, so we're going to set up Pythagorean theorem. 22 squared plus x squared equals 25 squared. 22 squared plus x squared equals 25 squared. All right, 22 to the second power is 484. plus x squared. 25 to the second power is 625. Alright, and then we subtract 484 minus 484. And we get x squared equals 625 minus 484. And we get 141. Alright, last step. To get rid of an exponent of 2, we square root both sides, and the square root of 141 is 11.87. Okay, x equals 11.87 ... But if we're rounding to the nearest tenth, we would actually round this to 11.9. Any questions? Wonderbar. Moving on. All right. JK is a tangent line, which means this is a 90-degree angle. We got to solve for x. Hey, if J is the 90-degree angle and this is a right triangle, which one's the hypotenuse? The x, because it's across from the right angle. All right. One of my legs is 6.4. My other leg is going to be how long? Should be 7. The reason why is MJ 7? 3.5 is the radius, which means this radius is also 3.5, and if I add them together I get 7. So I'm going to do 7 squared plus 6.4 squared equals the hypotenuse, which is x squared. 7 squared plus 6.4 squared equals x squared. 7 squared is 49. I know that one. 6.4 squared is 40.96. I know we're rounding to the nearest tenth, but we'll do that at the end. Okay, equals x squared. If I add these two guys together, I get 89.96 equals x squared. And then if I take the square root of both sides, I get 9.48. X equals 9.48. And since we're rounding to the nearest tenth, I would round this to 9.5. Alright. Okie dokie. Moving on. Numero ocho. Alright, JK is the tangent line, just like all of these, because it says it in the directions. JK is tangent. So JK is the tangent line, which means J is my point of tangency, because that's where it touches the circle, which means here at this point of tangency there's a 90-degree angle, which means JMK is a right triangle, which means in order to solve for x, I could figure out what is the... in order to solve for x, I could use Pythagorean theorem. Alright. Alright, which one's my hypotenuse here? 7. Is it going to be this diameter here, or is it going to be 25? 25 is going to be my C, because it's across from the right angle. So I'm going to do 7 squared plus, how long is JM? Well, JL is x. Okay. LM also is x. And what's x plus x? X plus x is 2x. I bet you some of you just said x squared, which is not correct. X times x is x squared. But if I'm figuring out the length here, I would just add x plus x, which is actually 2x, not x squared. All right. So 7 squared plus 2x squared equals 25. Yep, that's right. So 7 squared plus 2x squared equals 25 squared. All right, 7 squared is 49. 2x squared is actually 4x squared. And 25 squared, I remember that one from before, is 625. All right, we want to get the x by itself, so we're going to subtract out a 49 from both sides. This will cancel, so I have 4x squared equals 625 minus 49, which is 576. All right, now I have to get the x by itself. There's an exponent up here, there's a coefficient of 4 out here. Which one do I have to get rid of first? I have to divide out the 4 first, okay? Because of order of operations, we have to go backwards. So we would do the exponent last, okay? When you're undoing the operations, you go backwards. So we would divide out a 4 first. So I get x squared equals 576 divided by 4, which is 144. And I actually know this one when you take the square root of both sides here. The square root of x squared is x. The square root of 144, I believe, is 12. All right. Any questions? Beautiful. Moving on. All right. Okay. Let's see what's going on out here. Do I care about this one? Yeah, I guess so. All right. So JK is the tangent line, which means my right angle is here at the point of tangency. Okay. Which means that LK is going to be my hypotenuse. So I'm going to do x squared plus 20 squared equals however long LK is. All right. Let's set that up. X squared plus 20 squared equals, how long is LK? Well, out here is 10, but what about in here? How long is this piece in here? Well, it says LJ is x, and LJ is a radius. So is this piece here. If this is a radius here, and this is a radius here, they have to be the same. So if this length is x, so is this length here. All right. So what would I call LK? X is this piece, 10 is this piece. If you want to find the length of the whole, you have to add the 2 parts. So this would be x plus 10. All right. So x squared, that's this leg's, plus 20 squared, that's this leg, equals the hypotenuse squared. The hypotenuse is x plus 10 squared. All right. X squared is just x squared. 20 squared is 20 to the second power is 400. And remember, what does this mean up here? X plus 10 squared. Well, if you square something, let's say you had 5 to the second power. What does that mean? What are you actually doing? You're not doing 5 times 2. You're doing 5 times itself, right? What if I had 20 to the second power? You're not doing 20 times 2, you're doing 20 times itself. So when you're doing x plus 10 squared, you're not doing x plus 10 times 2, you're doing x plus 10 times itself, x plus 10. Now, this is something that you guys probably haven't done since Algebra 1, okay? But this is the multiplication of 2 binomials. They're called binomials because they have 2 terms each. All right, and there's a way that you learned how to do this. I don't know how they teach it at the freshman center. They might have called it double distribution. They might have called it FOIL. That might ring some bells, okay? But in order to multiply 2 binomials together, you have to do 4 different multiplications. FOIL stands for first, outside, inside, last. And that's the order that you're going to multiply. You're going to take the 2 first terms, x and x, and multiply them together. Then you're going to take the 2 outside terms and multiply them together. Then you're going to take the 2 inside terms. They're on the inside, see? And then you're going to take the 2 last terms and multiply them together. Okay? You're basically just taking the first term, multiplying it, and distributing it. Then you're taking the second term, and you're distributing that. So there's 4 different multiplications. All right, let's see what that comes out to. Over here I have x squared plus 400. That's just carried down from the top. X times x is x squared. X times 10 plus 10x plus 10 times x, 10x. 10 times 10 is 100. And now I'm going to combine like terms. All right, over here I have x squared plus 400 equals x squared. Combine your like terms. 20x plus 100. All right, now I'm running out of room, but remember, we want to get the look what happens. We want to get the x by itself. Okay, look what happens when I start subtracting. Okay, if I subtract out an x squared from here and move it over here, look what happens. X squared minus x squared cancels. X squared minus x squared cancels. So what am I left with? I'm gonna finish up here. Okay, I'm left with 400 on the left equals 20x plus 100 on the right. 40 equals 20x plus 100. And now this is just a 2-step equation. Minus 100 and you get 300 equals 20x. And when I divide out my 20, let's see, 20 goes into 100 5 times, so it goes into 300 15 times. So x equals 15. All right. Okay, just a few more and a couple of other things that we have to talk about. Tangent lines. Let me put my paperweight back down. Okay. More tangent line properties. It says if 2 segments from the same external point are tangent to a circle, then they are congruent. Now, that's a little wordy. Let's break it down. 2 segments from the same external point. What does the word external mean? Outside. The word external means outside. So a point outside of the circle. That would be point B here. So if I have 2 tangent lines that extend from the same point that's outside the circle, that means they're congruent to each other. That means they're the same length. Okay. We will talk about the other part in a second. Let's just go with this for now. Okay. 2 segments from the same external point are tangent. That means they are the same length or congruent. So if I need to, in number 10, solve for x, well, it looks like these 2 tangent lines, because it says assume that the segments appear to be tangent, are tangent. So we're going to assume that these are tangent lines because they appear to be tangent lines. All right. And now, what do I know if I have 2 tangent lines that extend from the same external point? Well, I know that they are congruent or equal to each other. So if I need to find x, I'm going to take 5x plus 23, and I'm going to take 8x minus 19, and I'm going to set them equal. All right. So I would subtract 5x here minus 5x here, and I get 3x minus 19 equals 23. And then when I add 19 here, add 19 here, I get 3x equals 42, right? Yeah, 42. And then when I divide by 3, 42 divided by 3 is 14. Easy enough? All right. Number 11 is the same exact thing. It actually ends up coming out to be, it's the same exact type of question, okay? These 2 are equal, So set them equal. You can try that one on your own. Okay. The only difference is here you have to find PQ. All right, I guess we'll do it together. So since they're two tangent lines from the same point, that means they're congruent, which means I can set them equal. 14x minus 13 equals 8x plus 5. All right. Minus 8x minus 8x. This would be 6x minus 13 equals 5. Plus 13 plus 13. 6x equals 13 plus 5 is 18. Divide by 6, divide by 6. X equals 18 divided by 6 is 3. This one is a tiny bit different though, because it wants to know what's the length of PQ. So I am not done. I got to plug this back into 14x minus 13. 14x, which is 3, minus 13 equals 14 times 3 is 42 minus 13, and 42 minus 13 is 29. So how long is PQ? PQ is 29. All right. Okie dokie. All right, find SV. Well, it looks like ST and SU are tangent lines, and it does say that we can assume, since they look like they're tangent, we can assume that they are, which means ST and SU are congruent, which means 4x plus 7 and 10x minus 41 are equal. 4x plus 7 equals 10x minus 41. All right, minus 4x minus 4x. I get 7 equals 6x minus 41. And then when I add 41 to both sides, I get 6x equals 48. And when I divide by 6, I get x equals 8. Now, they want to know what's the length of SV. SV is this guy right here. That's what we're looking for here. How long is SV? Whoa. Any ideas? Well, what else do we know about tangent lines? They create what kind of angles at the point of tangency? They create right angles. That's true. Which means that this has to be a right triangle, which means that SV is a hypotenuse, so that could be my C if I use Pythagorean theorem, and then my two legs would be 17 and however long ST is. Well, I know what X is, so I can figure out how long ST is by plugging in 8 for X. 10 times 8 minus 41. Let's see, that would be 80 minus 41. 80 minus 40 is 40, minus 1 more is 39. So if I want to figure out how long SV is, I have a right triangle here, so I would do 17 squared plus 39 squared equals my hypotenuse, which we'll call C squared. So we'll do that over here. 17 squared plus 39 squared equals C squared. 17 squared is 289. 39 squared is 1521 equals C squared. If I add these two guys together, 1521 plus 289, I get 1810. And then last but not least, square root, and I get C is the square root of 1810, which ends up being 42.544 ... let's keep rounding to the nearest 10, tenth, might as well. So I would round this to 42 point. We keep it the same because of the 4, so 42.5. And that's how long SV is, which is what we were being asked to do. So SV equals 42.5. All right. We got dos más. That's 2 more for those of you that don't know what that means. So I'm gonna shoot back up to this more tangent line properties, because there's one other thing that we didn't talk about. If a polygon is circumscribed around the circle, that's a word we haven't talked about, circumscribed around the circle. But I think that you can figure out what that means. They're talking about, in this case, the triangle ABC is circumscribed around the circle. And all that means is it's outside the circle, okay? And all of the sides of the triangle are tangent to the circle. So D is a point of tangency, E is a point of tangency, F is a point of tangency. They all touch the circle at exactly one place. All right. Then all of the sides are tangent. Now, think about this though. BD is tangent, BE is tangent because it touches at 2 spots, and they both originate at the same external point. What do we know about that? Well, I know that if a tangent line extends from an external point, that the 2 tangent lines are congruent. So this piece is congruent to this piece here. Also look down here. I have tangent line FC and tangent line EC that both extend from the external point C. So what does that mean about FC and EC? These 2 are congruent to each other. And last but not least, over here, okay, I have AF and AD. Okay, they are tangent. Okay, which means they touch once. They both originate outside the circle at the same point, which means AD is congruent to AF. So if ever you have a polygon, which is just, it could be a triangle, it could be a quadrilateral, okay, it could be a pentagon, okay, whatever it may be, at the external point, you have 2 congruent pieces on either side. External point, 2 congruent pieces, external point, 2 congruent pieces. So using that information, let's jump down to number 13. Stupid motorcycle. Find the perimeter of DEF. So they're talking about, I'm gonna use my handy dandy highlighter. Okay, they want us to find the perimeter of that triangle. Who remembers what perimeter means? That's right, add up all the sides. All right, so what do we know? We know we have a triangle, DEF, okay? Let's start over here. It says HE is 16, but IE and HE both go to E, and they're both tangent. So if HE is 16, IE is, you got it, 16. Down here, IF and GF both go to the same point, F, outside the circle. So if IF is 9.5, guess what? GF, 9.5. And last but not least, I have DG and DH. They are both tangent lines that originate outside the circle at D. So I have DG is 11. Guess what? DH, also 11. So all I'm going to do is add up all the sides now to find the perimeter. Okay, out here 11 plus 16, this side is 27. Out here this side is 9.5 plus 16. Well, 16 plus 10 would be 26 minus 0.5, that would be 25.5. 11 plus 9.5, 11 plus 10 would be 21 minus 0.5, that would be 20.5. So those are my three sides: 27, 25.5, and 20.5. And then when you add them all up, because that's what perimeter is, when you add all those together, you get $73. There's your perimeter. All right, last one. Then I'm gonna go do some yard work. Find the perimeter of quadrilateral PQRS. All right, this one's a little bit trickier. Okay, so we have a quad. All right, outside, circumscribing the circle. All right, so remember, if this piece is 27.1, that means that this piece here is 27.1 because they're both from the same external point. Okay, moving on. All right, how long is this piece here? Well, I have the whole thing is 52.5 and this part is 27.1. Okay, so if I just subtract 52.5 minus 27.1, that'll give me this piece over here. 52.5 minus 27.1, I get 25.4. So that's how long this piece is here. Which means, since these are both tangent lines that extend to point S, if this is 25.4, guess what? This is 25.4. All right. Okay, so since P, well, this point doesn't have a label, but since this part here is 23, that means, since this point here is 23, how long is this point? Gotta be 23, since they go to the same exact external point at point P. And now, how long is this piece out here? Well, in order to find this piece out here, I know the whole thing, PQ, is 37.5. I know this part over here is 23, so what do I do with these two to figure out this piece? Subtract 37.5 minus 23, and you get this piece here is 14.5, which means, guess what? This piece here, also 14.5. They want to know the perimeter, so add everything up. 14.5 plus 14.5 plus 27.1 plus 27.1 plus 25.4 plus 25.4 plus 23 plus 23. So perimeter is 180. And that, ladies and gentlemen, is tangent lines. That was me dropping the mic. All right, so your homework is going to be due on Wednesday evening. Okay, you'll have 2 days to do it. I'll post this on Tuesday morning. You guys will have all of Tuesday, all of Wednesday to complete it. And I hope you guys are doing well and stay healthy and wash your hands. And I'll talk to you soon. Adios.